Welcome back. This is the second lesson recording for IM1, November 13th, 2020. So now I'm going to ask you to pause the video and complete card number 8 to 14 of the decimals. So card number 8, this is where you get to sketch the line of best fit. So use the sketch function to sketch a line of best fit for the given scatter plot. That means to do that, I am going to call my line tool, and I can maybe draw a line going from something like this, okay? Because we're looking for the points, the line to follow the trend, as well as maybe approximately same number of points above as below. Maybe I didn't do this so well there. Okay, then let's move on to the next one. Use the sketch function to sketch a line of best fit again. All right, so maybe somewhere like something like this. Okay, all right. So I have like 4 points below and about 4 points below above, when that seems to follow the trend very well. Okay, and use the sketch function to sketch the line of best fit for given scatter plot. So this time the points seem to be decreasing. So it's a negative association. So maybe something like this. Okay. Then 11. Okay. Seems to be opening up at the top, but I can still draw a line. It still does look linear. So maybe something like this. Okay. And finally, this one. Use the sketch function to sketch a line of best fit for given scatter plot. Okay, so maybe that's something that looks like this. Or maybe I should have started somewhere more closer to here. Maybe this will be better. Okay. All right. So if I just go back to all the cards that I've created, the line of best fit, this one, okay, they seem to follow. But again, I'm eyeballing it, right? I mean, is that best? And because like my line of best fit is going to look very different from my neighbor's line of best fit, even given the same points. They can't all be right. So what do we do? Well, right now we are just drawing the line of best fit, eyeballing it. However, later on we will find that the computer will be able to take all these data points and figure out the distance from the line and figure out what is indeed the line of best fit that takes into every single point. Okay, so the computer is able to do that. But for now, so that you understand how the computer is doing it, you're doing the line of best fit. Okay, so let's get back to our slide. Making prediction. The lines of best fit allows us to make predictions even though we don't have any data point. So to investigate that, I would like you to go on to card number 13 to 19 of Desmos. Okay, so this is card number 13. It says predicting using line of best fit. Let's read the write-up. The local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are the figures for the last 12 days. X represents the temperature in C, and Y represents the ice cream sales in dollars. Okay, in C means Celsius. Okay, so then we are asked to move the black and green dots to create the line of best fit. Before we do that, I do want to make some sense of this data we have. So what is the x-axis? That is the temperature in some Celsius. This is the temperature in Celsius, degrees Celsius at noon, whereas the y-axis is amount of money made, ice cream sales. Okay, so dollar made from sales. So that means that as the temperature gets higher or as it gets hotter, it looks like they were able to make more money. So that's what those dots made from many different days gives us a good information about trend line as well as what we can expect. So let's start by moving the line of best fit. Okay, so let's move that. Okay, so let's move this. Okay, so that looks pretty good. It needs to follow the trend and it needs to be approximately about the same number. Let's go through as many points as possible. Let's see, how does this look? Okay, maybe a little closer. Okay, there, that's my line of best fit. I have one. Oh, that looks like too many, lot more points above than below. Okay, so I have 1, 2, 3, 4, and I have approximately the same number below and above. Okay, so that's my line of best fit. Then let's move on. Okay, let's clear that. Now, interpolation. What is interpolation? Interpolation is where we predict a value that is within the domain or range of our existing data points. So you see, we have all these data points represented by these yellow dots. And we're making a prediction about what if the temperature was 21 degrees at noon? How much do you think will be the sale that we can predict? Okay, so then even though we don't have any days that had recorded 21 degrees as the temperature at noon, we can use that to predict if it was 21 degrees, we can expect to sell approximately $480. Okay, so that's interpolation because inter means inside. Okay, inside you're making predictions inside the data points that we're given. In contrast, the next slide tells us about extrapolation. Extrapolation is where we are predicting values that is outside the domain range of our existing data points. So we have yellow dots representing the data points from when x is 12 degrees to when x is, say, 25 degrees, okay? But we are going beyond the temperature range that we have record of. So we're going to 29 degrees here. So when we extrapolate, we usually have to extend our line of best fit. And in this example, using the line of best fit as our model, when the temperature is 29 degrees Celsius, and it's extrapolation because we're predicting outside the data points, the sale of the ice cream is predicted to be $750. So here, okay, at 29 degrees Celsius, where is the graph? Find the graph by extending the line of best fit and then find the y value for that x value, which comes to $750. So we are predicting if the temperature was 29 degrees, then we would expect to sell maybe around $750 worth of ice cream. Okay. All right, then predicting using line of best fit. Use the line of best fit to predict the temperature when the ice cream sale is $300. So ice cream sale is $300. Remember, ice cream sale is the y-axis. So I am going to just write it. This is the ice cream sale. So if the ice cream sale is 300, then this is 500, this is 0. That means this has to be 300 here. So we are looking at this point and we're looking for what is the temperature. The temperature is the x-axis. So we're looking to go down here. What is the temperature right here? That will be, this is 0, this is 10, this will be about 15. So I would expect the temperature to be 15 degrees Celsius if the sale is $300. And I would write something like that here. Okay, card number 17. Based on the line of best fit, what is the lowest temperature that people will still buy ice cream? Okay, so remember the x-axis is the temperature in Celsius, the y-axis is ice cream sale. So if people are still buying, that means they are selling something. At least they're selling something. So when they're not making no sales, that will be here. So what is the lowest temperature? I would say about here. So this will be when they sell no ice cream whatsoever. So I would say this is 10 here, so this is 5 degrees. So it has to be above 5 degrees if there is to be anybody still buying ice cream. Okay, any line of best fit can be represented using the equation as well. The equation for our ice cream situation is y is equal to 30x minus 160. Explain how you can use the equation to predict ice cream sales when the temperature is 10 degrees. Find the prediction. So what do we know? What is x and what is y? X is the temperature in Celsius. And what is y? That is the amount of sale. That's ice cream sale in dollars. Okay, so explain how you can use the equation to predict the ice cream sale when the temperature is 10 degrees. If I was to just look at the graph, I will go to 10 degrees and find here, and then find this point, and I would say, okay, so at 10 degrees Celsius, I would expect to have approximately $150. Okay, how about using the equation? I can do the same thing. The temperature is 10 degrees. That means x is 10. So y is what we're trying to find. So y is 30 times x is 10. So 10 minus 160. 30 times 10 is 300 minus 160. That's 140. Okay, so that gave a little more accurate answer than just going from the graph, because graph is not going to give me as accurate an answer. While if you have an equation, that's going to give me far better. So I know that according to the equation, I will have approximately $140 worth of sale. According to the graph, I would have guessed about $150. They were close, but equation was more precise. Okay, so now this is the last card that we're going to be working on. Here's the graph of our ice cream sales with the equation y is equal to 30x minus 160. What is the slope? Explain what does the slope mean in this situation. Remember slope. What is the slope from this equation? Slope is always, there's two numbers on a equation. There is the number that is in front of the x, and that is, or the number that is being multiplied to x, and that is slope. And in contrast, the number without the x, we said that is the y-intercept. Okay, and we can check that. What is the y-intercept in this case? We're told that y-intercept according to this equation is 160. 160, is this approximately where the graph is crossing the y-axis? Yeah, this is negative 100, and this is negative 150, so 160 would be approximately right. And 30x, what does 30x tell me? This is the unit rate. That means every time the temperature changes by 1, how much will the ice cream sale, or how much the y-axis will change? This tells me that every time the temperature at noon increased by 1 degrees, I will have increase of $30 for each of the 1 degree increase in the temperature.